So we're just going to have pi r squared. Our radius is 3, so it's just pi times 3 squared, which is 9 pi. Well, that one's 9 pi, which means the other circle is also 9 pi. I know the height of my rectangle is 15, and I know, I don't know the width. Oh, they didn't give me the width. I can't do it. It didn't give me a width. Gracie? Oh, the circumference of this. Oh, because it wraps around that circle, right? So we need the circumference of the circle, which is going to be 2 pi r, which is 2 times pi times 3. So this inside is going to be 6 pi times 15. So my surface area is just adding up those two-dimensional shapes. So it's 9 pi plus 9 pi, which equals 18 pi. Plus 6 times 15 is 90 pi, which equals 108 pi centimeters squared. Don't forget about the centimeter squared. Cool. All right. Let's go right into homework questions. Any questions on the homework? None whatsoever? Let me just create questions. It's not really, so we don't have questions. I'm just going to go over them really, really quickly. I just want to make sure that we actually understood what was going on. And those two in the barn one. All right. I'm assuming you all have the right answer because you probably checked online, hopefully, and that's why you don't have questions. I'm just going to tell you kind of how I think about these problems. All right, so you're not spending a ton of time on the test. What I think about it is, I think about, this is a rectangular prism, because a prism has a base and a top. So I think of it without a hole. All right, I pretend like there is no hole, and I calculate all of the different areas. So the first thing I did was I did these sides. I looked at that side, and I said that's 10 times 4. Well, I have 2 of them on either side, so it's 2 times 10 times 4. Then I went ahead and did the top. I looked at that top. Well, that top is 4 times 8, but I have a top and a bottom, so I have 2 of them. And finally, I have that front face. And I'm just pretending like it doesn't have that missing circle. So I look at the shape of that face. That's 8 times 10. I have a face, and I have a backside, so that's 2 of the 8 times 10. Now I'm going to subtract out the circles. All right, the circle from the front. The circle from the back would be 2 of these pi times 2 squared, because it's pi r squared. The diameter was 4, so my radius is 2, so I just subtracted those 2 circles out. And this would be my total area of just the front, if I had to buy paint for just the front, the top, the 2 sides. However, I also have to paint this inside cylinder. So add that inside cylinder in. I just said, well, the length of the cylinder is 4. And I multiply it by the circumference of the circle. So this is that inside cylinder, 16 pi. I add that to the 304 minus 8 pi, and I get 304 plus 8 pi. All right, so that's how I think of it. I come up with the total area, subtract out those missing parts, and then add in that cylinder. Same thing happened over here. I just calculated our total area right here. I subtracted out the hole in the circle, and then just added in that cylinder.
Shouldn't it be a hole with an H?
Yes. It should be hole with an H. I think I got so used to writing like whole circle, part of circle kind of thing that I just...
Okay.
But it should be whole in circle. Yeah, it should definitely be an H. Otherwise it'd be the whole of the circle. I don't know. It should be an H. Good job. All right. Really quick, too. I just want to talk about the barn one. The barn one is feasible. I could ask this on a test. I probably wouldn't ask this full question. I'd probably just say, what is the surface area of the roof? Or what's the surface area of all of the walls? But it's all very doable. And this is how I broke it down. And I think this is the easy way to look at it, is I break it down to every single piece. I said I have a triangle at top. I calculated the triangle's area and multiplied it by 2 because I have a front and a back. Then I said I have a trapezoid. So I calculated the area of a trapezoid. Remember, the area of a trapezoid is half our height times base 1 plus base 2. That's why we have 12 plus 30 in this. And then I had a front rectangle. I put right there, and I have 2 of the long rectangles, and that came up with my total surface area. All right, so I think this is the easiest way to organize things, and I like to draw little pictures. It helps me know, because just looking at these pictures, you know where it came from, right? Just drawing triangles, you know it came from there, and I worked my way down the side of the barn. So you can kind of picture the whole side of the barn right here, and it's the other side. All right, so the only problem with this is just keeping things organized. Okay, so it's just about organizing. Today we're going to talk about volume. So we talked about surface area. Surface area was adding up our two-dimensional objects. So we're kind of picturing an empty object in there, right? If I make a cylinder, I'm just worried about what's on the outside. The inside is empty. Volume is, I want to calculate everything that's inside of that cylinder. I want to calculate whatever's inside of that rectangle. If I fill it up with water, how much water can I actually fit in there? That is what we're talking about in volume. In short, you kind of look at it as the left-hand side, and it's cubes in a box. How many of those cubes can I fit in that box is going to be my volume. And each of these cubes is going to be 1 by 1 by 1. So if I was actually to construct this cube, let's make it a little bigger. If I was to actually construct this cube, which I wish I would have kept my cubes from my old school, but if I constructed this, it would be 1 by 1 by 1. So it's 1 cubic unit, 1 cubic centimeter, 1 cubic foot. And volume is how many of these cubics can I actually fit inside this box? And that's going to be my volume. All right, so volume includes length, width, and height, and includes everything in there. So we can picture all of those boxes being lined up inside of here as well. Now, this way of looking at volume works only if it's a rectangular or square prism. In other words, if you have a cube, or if you have like a rectangle box shape, this kind of method works where you can do length times width times height. A much better way to look at it, a more applicable to other shapes, is going to be thinking about it like this. That if I calculate the area of my base, and I stack that on top of itself, and stack it again, 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 I will have a three-dimensional object of this shape. All right? And in order to calculate the volume in this method, all we need to know is the area of the base and the height. So the way I think about that is, I work with wood, so I think about, I'm going to cut out of wood the shape of my base. And I'm going to stack another piece of wood on top of that. Another piece, another piece, another piece, another piece, until I get this total shape. So all I need to know is how to cut out that original base and how high I have to stack it. And I have volume. All right, that's what they're showing right here. So the only two things we need, area. Do we know how to calculate area?
Yes.
Of like a square, of a rectangle, of a circle? Yeah, that should be an easy part. The only thing I'm adding into this is height. Do we know how to read numbers? Do we know how to multiply numbers?
No.
No? Okay. Oof. Don't work on multiplying today. But all we need to know today is how to calculate area and how to multiply by a height. That's all we're adding in with volume. All right? So let's go ahead and see some examples. So our first example is kind of an odd shape. It's kind of an odd duck. So let's talk about volume really quick. Volume is supposed to equal area of base, times my height. And note this only works on cylinders and prisms, okay? Because obviously a triangle, you can't keep the same shape and build it up. You have to keep going down in size, right? If I have a pyramid and I cut out the base, I have to have a slightly smaller base, smaller. So those are going to be different. But if it's just vertical like this, we just need to get the area of base and multiply it by its height. So I need to figure out how I'm going to cut out that base. If I'm a woodworker, I'm going to cut out that base. So I'm going to zoom in on just the base. That's a terrible drawing. It probably won't be better the second time either. Okay, so that's my base. And I need my dimensions to know how to cut it out. Well, this is 8. This is 3. If we look up here, this is 5. What else we got? We got 9 running across here. I'm going to cut this into 2 little shapes, so I'm going to call this 8. This is 5. Well, if this whole distance is 9, and this is 3, this must mean this is 6. So the area of this is going to be the area of this section plus the area of this section. Well, the area of this section is just 9 times 8, which is 72. And the area of the other section is 30. So my total area is going to equal 102. I'm just going to call it centimeters squared. All right, I got my area of my base. So now imagine I cut this out, right? I cut this out and laid it on the floor. I'm just going to keep laying more and more on top of each other until I get to this height. So I just need to know how high I need to stack it. And I need to stack it 20 times. So we're going to go, our volume is going to equal that cutout shape that I did, so 102. I'm going to multiply it by that 20, which is going to be 2,040 centimeters. Centimeters what? Say it louder, whoever said it. Cubed. It's going to be cubed. We have 3 dimensions, right? We have length times width, and now we have height built in, so it's cubed. 3 dimensions means it's cubed. In other words, why it's cubic and why we say that word is because it's made out of cubes. Cubic. Weird that cube and cubic have the same root word. And that's because a cube has 3 dimensions. Cubic, 3. All right, the next one we have is cylinder. So remember that first method I said we could do, that I said we're probably not going to do much of, where I add a whole bunch of cubes in it? Would you want to figure out how many cubes fit in a cylinder? Yes. The problem with that is you have to have a bunch of partial cubes, right? Like you could throw cubes in there, but cubes eventually don't make a round, so you'd have to cut them and round them off and figure out what they are. So you'd have to do a whole bunch of sectors and, whew, that'd be a lot of math. Versus, if I cut out a circle and I just keep stacking it on top of each other, eventually I'm going to make this shape, right? So that's all we're going to do. We're going to pretend like I'm just stacking a bunch of circles on top of each other. So we cut it into different sections and we're just stacking it. Well, that looks just like that method that's right above it, where we just calculate the base and multiply by the height. Well, that just means I need to know what the base is. So I'll pull out a circle, and our base is pi r squared. So that would be pi times 14 squared. So that area of that is going to be 144, or 196. It's not 12 times 12. It's 196 pi, let's call it centimeters squared. So that's the base. I got to cut out of wood. Now I just got to know how high to stack it. I need to stack it 27 units high. All right, because each of my things is 1 unit in width. So I need to stack it 27 units high, so it's just going to be our volume. It's going to equal that 196 pi times 27, which is going to equal 5,292 pi centimeters cubed. Pretty tough, right? We had to add in multiplication. So hopefully multiplication isn't going too bad. We have calculators. We have calculators if we get stuck. All right, so that's if it's a cylinder. Well, this is part of a cylinder. It looks complicated. It looks like there's no way I can calculate this volume. Looks like I have to measure a whole bunch of stuff out. But once again, we're just going to calculate that base. We're going to cut out that base out of wood, and we're just going to stack it over and over again. So let's just draw our base. Kind of a Pac-Man looking shape. This is 100 degrees, which makes this 260 degrees. Can someone tell me the formula for figuring out the area of that? Because it's a sector of a circle, so it's not the whole circle. Marion, take a shot at it? Absolutely. We're just going to do 260. Let's just put our area, because that's area of a sector, right? Is going to equal 260. So the percent of the circle that's being taken up times the pi r squared, and r is 6 squared, which is going to end up equaling, I think it was 28, 26. Yeah, 26 equals 26 pi, let's call it centimeters squared. All right, that's my base. So I created my base. Now we just have to figure out how high I need to stack that base. And that's going to be 10 units high. So our volume is going to equal 26 pi times 10, which equals 260 pi centimeters cubed. That cube got away from me. Just going to shift that guy over a little bit so it's not in my way. And that's our answer. All right, let's go down the rabbit hole for a second. Look at D. If I look at this as the base, it's a rectangle, right? If I cut out a rectangle and stack it on top of each other, is it going to make this triangular shape? Remember, as soon as you make your base, you have to keep stacking it. That doesn't make a triangle, no. So what we need to do is, rather than looking at it like this, right, because right now we have that, and I'm thinking that's my base, I'm going to turn it on its side. Now if I cut out that triangle, and stack it on top of each other, is it going to make this shape? Yes, it will. So rather than looking at the base as always the one that's on the bottom, sometimes you have to think of it as being your left and right. So in other words, we're going to stack triangles on top of each other, or next to each other. So it's going to be something like that, and we'd continue on. So we're going to stack that way. So that means I need the area of the triangle. I need the area of this triangle. All they give me is the hypotenuse in the top, but it's a right triangle, so we would just use Pythagorean theorem. I'm going to let you do the Pythagorean theorem, but you should come up with 15. So a squared plus b squared equals c squared. You should get out 15. Which means the area of this triangle is going to equal half the base times the height. Well, that's just going to equal 4 times 15, 40, 20, 60. 60 centimeters squared. That is my base. So our volume is going to equal 60 times, here's where it gets a little tricky. Not really tricky. Would I multiply by 8 for my height? Gracie's saying no. What should I multiply by? 21, because we're going this way. That's why I did that drawing. So we're going to multiply by 21. So our volume is going to equal 1,260 centimeters squared. Cubed. Did I say squared? I feel like I said squared. I meant to say cubed. Okay, down below, I have some examples of prisms. This is what a prisms look like. So if I say it's a pentagonal prism, it just has a pentagon as a base, pentagon as top, and we just connect with straight lines. Same thing if it's hexagonal. 6 sides, straight up. Regular prism is a rectangle. You can also have square prisms, and you can have a square base prism. I think that's one of the problems. Also, you can have a triangular prism. You can either draw it horizontally or you can draw it vertically. A lot of times I draw it vertically just so I can make more sense of it. I do want to note something about cylinders. If it's straight up and down, it's known as a right cylinder. Because in the homework it says draw a right cylinder, and if I don't point it out, you'll be like, what's a right cylinder versus a regular? So this is a right cylinder. If it was tilted, it would not be a right cylinder. But right cylinder is just straight up and down, so have that note down. I want to go over a couple things on the homework. All of these are good problems. Number 4 is kind of a challenge question. Not really a challenge. It's you got a 50-50 shot of getting it right, because the base area equals 11.4. Now you just got to figure out what the height is. Some of these are hard to see, so I'm going to go over. Number 9. You should be able to see this, but this is 12. This is 90 degrees. What you cannot see is there's actually a 3 right here. So the radius equals 3 on that guy. All right, you need to know that. All right, then moving along, another one that didn't photograph well is this one. You can kind of see it, but we don't know the height right now. This height right here is actually a 3. So that's actually a 3, so either put it there or just put a little note to yourself that the height is 3. Real quick on the, would it make sense to cut out the base like this and stack it? No, so you probably have to think of something else. It's probably a lot like that triangle problem. Number 11, we have to figure out how to come up with a half a circle, subtracting 2 smaller half circles, because we just need the base times the height. All right, even though it looks like a crazy weird shape, a little moon, kind of looks like a moon. Heptagonal, does anyone know how many sides a heptagon has?
7.
It is 7, yep, it's 7. All right, let's go ahead and get started on the homework. I'm also going to walk around and I'm going to check your homework for today.